In the problems that follow, we're presented with two facts about geometric figures. These facts form a system of equations, and this system can be solved in a variety of ways. Okay? So, a rectangular enclosure has an area of 384 square feet, but its perimeter is only 80 feet. So let's look at fact number 1. List possible lengths x and y, the lengths x and the widths y, for rectangles with an area of 384 square feet. Okay, you all have your calculators on your desk. Okay, how would we find the y if we know the x? We would divide the area by x, correct? Okay, so you all have your calculators. Every one of you guys do a different one of these. I'll give you just a second. We'll fill this table in real quick after that. Okay. All right. Somebody have 10? What's y if x is 10? 38.4. What's y if x is 12? 32. What's y if x is 14? 27.43. Okay. What's y if x is 16? 24. What's y if x is 18? 21.33. What's y if x is 20? 19.2. Okay, what two other values do we want to put here? 30 and 40. Okay, first of all, does it matter what we put there? No, we're just getting other examples, right? So what is y if x is 30? 12.8. And what is y if x is 40? 9.6. Now, remind me again, because we did that pretty fast, remind me again how we got our y's. We took our area, and area is length times width, and we have our length. Divide the area by the length to get the width. Very good. Which leads us to this box right here. It says in this case what equation relates them. Well, you just told me area is length times width. But we found the y value by dividing the area by the length. Yes? Okay. So that's area side. What about perimeter side? We add up all the sides. Okay. Is there some sort of mathematical equation we can use to find perimeter? Do we want to write x plus y plus x plus y? Or is it easier to say, how many x's are there? 2 x's. And how many y's are there? 2 y's. So 2x plus 2y should equal the perimeter, right? Okay, so 2x plus 2y should equal the perimeter. So in this case, 80, right? But we're trying to find y. How could we do that? If I'm trying to solve this for y, what do you want to do first? Minus 2x from both sides. 2y equals 80 minus 2x. Divide everything by 2. So if I know x, what am I doing with it to find y? Subtracting it from 40. So if x is 10, what is y? 30. If x is 12, what is y? 28. If x is 14, what is y? 26. If x is 16, what is y? 24. 18. 22. 20. What do we want to put in here? 30 and 40. Okay, we can do that. It's going to make it pretty interesting though, isn't it? Because if it's 30, what do we get? 10. And if it's 40? Uh-oh. Is that a rectangle anymore? No, it's not, is it? Okay. So, I mean, that's a frowny face right there. Okay. If you have two tables based on, let's fill in the equation. We kind of already did it up here at the top, but let's make sure we put it in the right box. What equation relates x and y? Yeah, for sure. Both of them do, right? Don't they both mean the same thing? Like we had 2 here, so we can have 2 here. 2x plus 2y equals 80 was the original equation, and we solved that for y to be y equals 40 minus x. Yes? Thank you. Okay? Now, if I give you two equations, thinking about what we talked about for the last couple days, and then even back in September, if I give you two equations, that makes a system of equations, right? Where is its solution? At the intersection, right, where they cross, okay? Can you tell by looking at a table the point of intersection? You can see which one they both have, can't you? Do you see how they both have 16 and 24? Okay, so which ordered pair appears to solve the system? 16 and 24. Is there another possibility? It is not on the table. You're right. What about this? Wouldn't that also work? Okay. Now, let's graph the system then. And then we can prove it, can't we? So I'm going to start a new document. That is a graph. And in the first function, I'm going to put y equals 384 over x. And for my second function, I'm going to put y equals 40 minus x. Now I have an idea. Wait, did I break it? Okay, yeah, that's what you guys always say. When you graph it and nothing shows up, you're like, oh, I broke it. You didn't break it, you just can't see it, right? Where do we think our solutions are going to be? Neither one of those are on this window, are they? We have to adjust our window. Menu, window, window settings. How low do we want to go? Does 0 make sense? Are we going to have anything below 0 at all? Can we have stuff above 0? Yes, so 0 would be good. Sometimes people want to put -1 just so we can see the axis. Just so you know. Okay, either one of those is fine. What x value do you want to go up to? So I want to go up far enough to be able to see both of these. Probably 30 would be a good place to go. You okay with that? I don't care how it counts. I'm going to let it choose. What about y? How low can it go? 0 again? Guys, why can't it go any lower? We're talking about a rectangle, right? A physical object. Can we measure -1 feet? No. Okay. So 0 and then where? A 30 again? Okay, that's fine with me. Oh, look, it does intersect twice. Let's find it. Menu, analyze, intersection. Click. Yeah, one at a time. For the record, I haven't clicked it yet. I'm going to pull it on the other side of this other intersection, and you can see how it only does that one time. I told you that the other day, but there's an example of that. Menu, analyze, intersection, left side, right side. Oh, look, it's exactly what we thought it would be. Okay. Now, do you want to have to go through this mess every time? And I mean, mine is not a mess. It's very neat, right? So it's not really a mess. It's just work that I need to make sure you understand what's happening in the tables. And once you know what's happening in the tables, am I going to have you do it every time? No. Okay, so you understand what's happening in the tables, right? Okay. So, triangles. Are you comfortable with triangles? Are you comfortable with rectangles? Are you comfortable with triangles? Are you comfortable with circles and squares? Are you comfortable with rectangular prisms? Well, you're going to be comfortable with them. Cylinders. Okay. So would you please circle the following problems? It's actually not a request. I should have said circle the following problem. No. Number 2. Okay. You can absolutely highlight them instead. Yes. So we're also circling number 4. So we circled number 2 and we circled number 4. I would also like us to circle number 7. And I would like us to circle 11 and 12. Okay? That gives us 5, yes? Do you have 5 circled? 2, 4, 7, 11, and 12. Yeah? So write your system, read the words, figuring out what's going on, write your system, solve your system. Can you solve it by graphing? Then solve it by graphing. What work will you show if you solve it by graphing? The actual graph, like draw the graph, right? But if you solve it, look, there's recommendations up here. See how this one, it's recommends you solving it by graphing. Then transfer your graph here, okay? But if it recommends quadratic formula or substitution, what work are you going to have? You're going to have that work, aren't you? Okay? Do you have any? You do not have to, but when it comes time, you're going to need to know how to do all 3 of these. So I would follow directions if I were you. Okay? You do have quite a few on here, I think 6, that you can do for extra points if you would like to. If you have any questions, just ask.